Hi everyone, we are going to take just a little bit to review how to find the area of a triangle. This should be something that you've already learned, so we're just going to talk about it pretty quickly. So remember that the height of a triangle is the perpendicular segment from a vertex to the line containing the opposite side. The opposite side is called the base of the triangle. In each of these three diagrams, you can see how the height and the base are labeled, but just remember that every triangle actually has three heights and three bases. You can turn the triangle or look at the triangle such that any of the sides could be the base. So for example, if this right here were the base, then the height would be here. And if this were the base, then the height would actually be here. So I don't want to spend a lot of time talking about that. I just want to remind you about that you can turn a triangle such that any side could be the base, and therefore the height would be perpendicular to that base. Let's just try a couple practice problems. Okay, so in this first one, we want to find the area, and we can see that this is our base because we have this line perpendicular to it, which is our height. That's the only perpendicular line that we have labeled, so we're going to use that as our height. Okay, so let's write our formula down. We've got area equals 1/2 base times height. We fill in what we have. The base is 16 and the height is 6. So when you do this formula, you can either multiply the 16 times 6 and then take half, or you could take half of one of the other numbers, which in this case would make this a little bit easier. We could do half of 16 first and get 8, and then 8 times 6, and we get 48. So our area is 48 square yards. Okay, in our second one, we have an equilateral triangle. In order to find the area of this, we are going to need to find the height. So if this is our base right here, which doesn't matter because they're all the same here, then we need to find that height. Let's talk about this one for a second. If each of these triangles angles are 60 degrees, then when I draw that height in, we now have a 30, 60, 90 triangle, which is really helpful right now. So if we have a 30, 60, 90 triangle, we know that this side right here is going to be 2, my short side. My hypotenuse is 4, and that makes this other side here 2 radical 3. That's my height. Okay, so now we take the formula, 1/2 base times height, and the base in this case is 4, and the height is 2 radical 3. So half of 4 is 2, and then 2 times 2 radical 3 is 4 radical 3. That will be centimeters squared. Next, we're going to learn about how to find the area of any regular polygon. You already know how to find the area of a regular triangle. We just did that. And I'm sure you know how to find the area of a square. But what if it's a pentagon or a hexagon or an octagon or something else? The formula we're going to learn next will work for any of those. We have to learn a new vocabulary word, though, and that word is an apothegm. An apothegm, first of all, that word always sounds funny to me. It makes you think of someone saying the word possum that doesn't have any front teeth. Apothegm. And now you're never going to think of that word the same. So an apothegm is a line segment drawn from the center of a regular polygon perpendicularly to any one side, but not to a vertex. When drawn perpendicularly, it will also connect to the midpoint of that side. So when you look at this example that I've already drawn in for you, this here is an apothegm. What is not an apothegm is when it goes to a vertex. Notice that that length is different. Sometimes we're going to use that also, and you're going to see that today in some examples, but the apothegm is the length that goes to the midpoint of a side, and it's specifically in a regular polygon, because if it's not regular, then each of those would be different. But in a regular polygon, if I draw in all of the apothegms, if I just draw them all in here real quick, these are all the same length when I draw them to each side. Of course, I'm sketching them here. And if they're perpendicular, they're going to be the same when it's in a regular polygon. Okay, so here we have 4 polygons to look at. We're going to draw one apothegm in each one. So in order to find the apothegm, we need to have the center of each shape. Let's just sketch that in. Okay, and then to make the apothem, we're just going to sketch one. There's the number of apothems in each shape would be the number of sides there are. So this triangle does have 3 of them, but we're just going to sketch one of them. It does not matter which one you draw in. And then you want to show that it's perpendicular. So then from our square and from the pentagon, we don't typically use the apothem in a square or triangle very often because there's other ways to find the area, where in the other polygons we need the apothem to find the area. But every regular polygon has an apothem. Okay, so the formula to find the area of any regular polygon is 1/2 AP, where A is your apothem and P is the perimeter. Okay, so I just want to point out a couple things about this formula. So we're just multiplying. So we've got 1/2 times A times P. And because of the commutative property, you can multiply that in any order that you want to and sort of group them in any way. So you can think about the associative property as well. So you could do, depending on which one's easier, like say A was a nice even number, you could take half of A first and then multiply it by the perimeter. Or maybe the perimeter is the number that's a nice even number. So you could do half of the perimeter and then multiply that by A when you're done. Or you could multiply A and P first, get that part done, and then multiply it by 1/2. What you don't want to do is take half of A and half of P and multiply that together. This would be wrong because the 1/2 is not getting distributed to both the A and the P. So just remember, you're just multiplying 3 things together, the 1/2, the A, and the P, and you can do that in any order. So you can take half at any time. Another way you might see this formula written down is you might see it as AP over 2, because it's really the same thing. So you could do it that way. You can multiply A and P together and then just divide it by 2. So 1/2 AP is your area formula for any regular polygon. For this example that we have written here, you already have it written down in your paper all worked out. I just wanted to walk through the example with you. So we fill in the parts here. We have the apothem is 7 inches. And then the perimeter, since there's 6 sides to a hexagon, and every side would be 8, you could just do 8 times 6 to get the perimeter of 48. So in this example, I would prefer to take half of 48 first because it's an even number and I can do half of that pretty easily in my head. So 1/2 of 48 is 24, and then 24 times 7. Well, let's see, 7 times 20 would be 140. 7 times 4 is 28, so I'm going to get 168. Now with area, when you give the label on it, don't forget that you're giving a square unit. So it would be square inches. So you can write it like that. You could also write it like this, square inches, but make sure that you put the appropriate unit on your label. The units are going to become even more important now that we're into area and pretty soon into volume as we think about the appropriate unit based on what type of thing that you're finding. So 168 square inches. Okay, I'm just going to do a couple of practice questions here about finding area of irregular polygons. As always, if you would like to try them with me or do them with me, you can just follow along. If you want to try them by yourself, you could pause the video and come back and check your answers. Okay, so for these examples, we are going to leave all answers exact as simplified radicals if there are any radicals there. We don't want to have any crazy decimals. And the first one, we want to find the area of a regular heptagon. That's 7 sides, with a side length of 8 and an apothem of 10. So we have our area formula, 1/2 AP, and in this case the apothem is 10, and then our perimeter will be, if each side is 8 inches long and there's 7 sides, that's 56. So I'm going to do half of 56 first, because I want to keep that 10. 10's a nice number to multiply by. Half of 58, that is 28, and then multiplied by 10. So I'm going to get 280 square inches. All right, number 2. Find the side length of a regular pentagon with an apothem of 6 and an area of 54. So now we're going to work backwards, where we're given the area, and we're going to work to find the side length of this regular pentagon. So we fill in our number. We know the area is 54, and the apothem they gave us is 6. And first we're going to solve to find the perimeter of the pentagon. So 54 equals 3 times p. We divide by 3 on both sides, and now we know that the perimeter of our shape is 18. So our last step is just to take this perimeter of 18, since it's for a pentagon and that's 5 sides, we just need to divide that by 5, and one side length is equal to 3 3/5, or 3.6 centimeters. Okay, if you notice in this question, we have the side length, which is 10. We know that. And we know that this length is 8, but this is not an apothem. This doesn't actually have a name. It's kind of like a radius if it was in a circle, but that side length is 8. So we're going to use the Pythagorean theorem that's in our hint here to go ahead and find our apothem. So we know we have a right angle because the apothem is drawn at a right angle to the side length. And so the hypotenuse is 8. And if the original side length was 10, and when the apothem gets drawn in, it gets drawn in at the midpoint, that means that half of that side is 5. And we're going to find that missing apothem, which is we're going to call x. So we're going to set up the Pythagorean theorem to help us figure this out. And we know that the hypotenuse was 8, so 8's going to get filled in for c. And our other two side lengths are 5 and x. So we have 5 squared plus x squared equals 8 squared. 25 plus x squared equals 64. And 64, subtract 25 from both sides, and we get 39. Take the square roots, and we get the square root of 39. So that's the apothem. Okay, so now we're going to go to our apothem formula, or our area formula. And the apothem is radical 39. And our perimeter, since it's a pentagon, there's 5 sides. 5 times 10 is 50. Okay, so next I want to do half of 50, and that's 25. And radical 39. And 39 does not have any perfect square factors, just has 3 and 13. So that's our final answer. And we'll put our unit here, which will be centimeters squared. So 25 radical 39 centimeters squared is our answer. All right, number 4. I'd really like you to try this one by yourself just to get the thinking through on your own at first. Walk through these questions where the blanks are, and then see if you can figure it out by yourself. If you're stuck, of course, come back and watch the video, but just try it. Take a minute, pause the video, and see how you did. Okay, so let's just walk through these questions. The first one says, what is the measure of an interior angle of a hexagon? You might have memorized this when we did the polygons a while ago, or maybe you can think about the formula. Formula is n minus 2 times 180, meaning that take the number of sides, which is 6, minus 2, which is 4, 4 times 180, and that gives you 720 is the total, and then you would divide that by the number of angles, so 720 divided by 6. So every hexagon has, every regular hexagon would have an angle of 120 degrees. So, and maybe you just have that fact memorized, which is a good one to keep in your head. Second one says to draw in more lines inside the hexagon, like the one drawn, to split it into 6 triangles. So if we just sketch these in, make it look like a big pie. And what kind of triangles are they? Well, if this whole angle here is 120 degrees, and we're dividing that in half, then each of those angles is 60 degrees. So if that's 60 and this is 60, then what's left up here will be 60. So this is an equilateral triangle. This is unique to hexagons. If you did this with a pentagon or an octagon, you would not get equilateral triangles. They'd be isosceles, but they would not be equilateral. If we draw in one apothem, let's just sketch one of them in. I'm just going to use this top picture up here. You can draw yours anywhere. Let's think about the kind of triangle that we just created inside that. So if this is 60 and we have a right angle right here, we have a right angle, then this angle up here, what's left for it is 30, or we can also see that we're dividing this 60-degree angle in half. So there's a 30-degree angle here. So we have a 30, 60, 90 right triangle. You know, we haven't talked about these a whole lot recently, but when we did 30, 60, 90 right triangles, we had special ways that we could find the side lengths of them. So just to refresh your memory on that, if you have a 30, 60, 90 right triangle, if this is x, and then this is 2x, and then this side is x radical 3, that's really helpful in a hexagon. So what I'd like to do to make this a little easier, let's take this triangle that we're looking at here, this one, and I'm just going to draw it again down here so we have a little more space to see what's happening. And there we go. And this is 60 degrees, and this is 30, and here's our right angle. So remember, we know that this length here is 5, right? So 5. So here, we know the hypotenuse is 5, and we know that this short side is half of that. We know that just because we can tell from the triangles, but we also knew that from our rule up here, that the short side is always half of the hypotenuse. So that's going to be 2.5, which makes our longer side, you do that length times radical 3. But rather than writing 2.5 radical 3, which can get a little weird having a fraction in front of the radical, I want you to think of 2.5 as 5 halves. So it's going to be 5 radical 3 over 2 will give me my long side. So we're multiplying that short side, 2.5 or 5 halves, times radical 3. So this is the radical, or the apothem length that we're going to need to use. Remember, our whole goal was to find the area of the hexagon, but we had to find that apothem in order to do that. So area equals 1/2 AP, which is 1/2 times 5 radical 3 over 2. And then the perimeter, one of our side lengths of our hexagon was 5. 5 times 6 is 30. All right, let's do half of 30 first. So that gives me 15. So I have 15 times 5 radical 3 over 2. 15 times 5, that's 75. 75 radical 3 over 2 is the area of the whole hexagon. And this was in inches, so that's inches squared.